Okay, here's H6. I think that you'll like this. It's pretty simple, and it shouldn't take much explanation from me. But okay, so we're gonna do number 2 and number 4 from the practice. So let me just read this and then I'll introduce something. So given the function f of x equals this, determine the absolute maximum value of f on this closed interval. So so we got to use something called the candidate's test for absolute extrema, okay? And the candidate's test goes like, it involves finding all of the candidates at which an absolute max or min could occur. And then it involves putting them in a table of values, finding the outputs, and then you look for the highest or lowest. So the candidates for where an absolute extrema could occur, and hopefully you remember from the last phase, absolute extrema can occur at critical numbers or endpoints. So those will be the candidates. They will be critical numbers that fall within the interval along with the endpoints of the interval. So the steps are this. First, we find the critical numbers. Remember from this page that is back in the document, this Cycle H document, that critical numbers happen where f prime is 0 or undefined. We have not yet encountered like an undefined situation when we're given a function because I haven't given you any functions that have a denominator. So the functions that we've been working with so far have all been polynomials, and those are defined everywhere. Their domain is all real numbers. So if you find the critical numbers, that is step 1. Then we're going to cross out any critical numbers that are outside of the given interval. Absolute extrema have to occur on a closed interval. Actually, absolute extrema. Only occur on a closed interval. They only occur in a closed interval. So then we're going to cross out any critical numbers that are outside of the given interval. And then step 3, we're just going to do a table of values like this. The left endpoint will be the first input. The right endpoint will be the last input. And then the critical numbers that we did not cross out will go here. And then we will get the corresponding outputs. For the corresponding outputs, we're going to plug into f. So we're only using the derivative to find the critical numbers. And then step 4, the highest output is the absolute max. The lowest output is the absolute min. Okay, so let's do it. So I already read this. So step 1 is to find the critical numbers. So this is the only part that you need the derivative for. This is the only part you need the derivative for. Negative 4x cubed plus 16x. Okay. Then we're gonna set this equal to 0. You can factor it first or later. We're gonna have to factor it anyway. Negative 4. This is not like the number line test. X squared minus 4 equals 0. All right, so this x plus 2, x minus 2. So x equals 0, x equals negative 2, x equals positive 2. All right, now our interval is from negative 3 to 1. So do any of these critical numbers fall outside of this interval? Yes, 2. So that is not a candidate. Okay. Outside of negative 3, 1. So we cross that out. So we have just completed steps 1 and 2. Now step 3, x f of x. So negative 3, and then what comes next is negative 2, and then 0, and then 1. Okay, so just like I said here, we start with the left endpoint, we put the critical numbers in here, right endpoint. And now we just have to get the corresponding outputs. And I've got a calculator in front of me, so I'm going to use it. I like to use the table for this. Like if you're plugging in a bunch of things into a function, you're not plugging into the derivative, okay? We're looking for the absolute maximum value of f, all right? Absolute maximum value of f, all right? So you're plugging into the original function. You only used the derivative to get the critical numbers because those were part of the candidates. All right, negative x to the fourth plus 8x squared plus 5. All right, and my table is on ask. So I'm just going to plug these things in. So -3, -2, 0, 1. All right, so -4, 21, 5, and 12. Absolute max. Okay, this is the highest. That is the highest y value. Okay, so absolute max is we could say 21 at x equals -2, or you could say 21 and then just tell your reader, you know, which is f of -2. All right, if you're stating a y value for these extrema things, you have to pair it with its corresponding x value. And it could have more than one corresponding x value, actually, in which case you'd have to just say all or both. All right, so guys, if you feel like you've got it, go just do your thing. I'm going to do number 4, though, if you want to stay with me. All right, so this one is optional to stay and watch because you may feel like you have it. Because 5, like this one is asking for an absolute min. Like in this problem, 5 would be the absolute min. Okay, 5 at x equals 0 would be the absolute min. But I'll do this anyway if anyone wants to see it. Okay, so first I need the critical numbers, and for that I need the derivative. -4x squared minus 36x. All right, I can take out a -4x, x squared plus 6x plus 9. All right, this actually ends up being that. All right, so x is 0, x is -3. Do either of these fall outside of this interval? No. Okay, so we're keeping them both. And then you go to this left endpoint, right endpoint. And then I will go to this, -x to the 4th minus 8x cubed minus 18x squared minus 1. I'm already on ask, so -4, -3, 0, and 1. Oh, yeah, this is a good one. Okay, so -33, -28, -1, -28. Okay, absolute, so we wanted the absolute minimum value of f. So the absolute minimum value of f is -28. All right. So I'll say it like this. I'll say absolute min, and I'll use function notation for this one. I'll say -28, but then I'm going to tell my reader this is happening at -3, and it's also happening at 1. So I'm making sure to indicate that. And then and I'll be like, or you could say -28 at x equals -3 and x equals 1. All right, I like function notation better. There it is.